Hello class, welcome to the three-way ANOVA example video. Unlike the two-way ANOVA example video, I'm not going to give you guys as much guidance for this video, particularly because so much of what we're doing in this example is very similar to what was done in the two-way ANOVA video or from the chapter 9 slides. But what I do want to do is just review some of the jump that you may need, or I'll say jump techniques and processes that you might need in order to work your way through this problem. So first off, just to give you a background, I'm going to go ahead and read the example problem. So the stress test example is from Kunter in 2005. And it's looking at the effects of gender, body fat, and smoking history on a subject. And we have our response exercise tolerance. And it was studied in a small-scale investigation of persons 25 to 35 years old. Exercise tolerance was measured in minutes until fatigue occurred when the subject was performing on a bicycle apparatus. 3 students for each gender, body fat, and smoking history group were given the exercise tolerance stress test. The data you need for this example can be found on eCampus in the file stresstest.jump. You can see that I've already pulled up that data on your left. So the first question in your example problems says state the three-way fixed effects ANOVA model corresponding to this data, and it asks you to be sure to define each term in your model and list any assumptions that are made. For this problem, you can find this information on slide 259 and 260. You won't actually need any jump for this problem. If you take a look at the second page, questions 2, 3, 4, and 5, pretty much all of these are going to need jump. Same with 6. Well, pretty much all of them as I'm going through. Except for maybe the last one, number 10, which kind of is asking us to synthesize our study. But basically, you're going to need 2 tools in order to do all the jump required for this three-way ANOVA example problem. So the first one comes up in question 2, and it asks if the model from question 1 is significant, and it asks us to state statistical evidence to support our claim. So all of these significance tests and asking for like effects test, we can find that in our fit model report. So if we go to analyze, fit model, exercise tolerance is our response. Gender, body fat, and smoking history are going to be our effects. Now I'm going to drop down and select macros full factorial. That's going to give us our main effects, our two-way interaction, and our three-way interaction. After this, I'm going to select run. And now when we have our stress test least squares output, a lot of this information we're really not going to need, at least to answer this, like the studentized residuals. I don't believe you're asked to do anything with the residual plot, but there it is. Effects summary we don't need, but we will need the effects test, and it doesn't show up automatically, but we are going to need the ANOVA table for our overall F-test. So in order to get that, we will select regression reports, analysis of variance. So here we have our overall F-test and our effects test, which is what we will look at to judge our two-way and, or well, three-way, two-way, and main effects, F ratios, and p-values. Another thing you're going to need to do is to be able to do your multiple comparison test. In order to do that, you may select the red triangle up where it says response exercise tolerance, select estimates, and then select multiple comparisons. What I recommend you do for this one is to select the test that you need, because remember, if you look at slide 262, you have a very specific flowchart. Step 1, we look at that overall F-test, which we can find in our analysis of variance. Then we check our three-way interaction, which we do with our effects test. Afterwards, we can look at our two-way interaction. If we have a significant two-way interaction, we will look at the significant pairwise comparisons. So for example, if we're looking at our effects test, we can see that body fat and smoking history has a significant p-value. So we're going to want to look at that effect test. So body fat, smoking history, I will select to choose that effect and select OK. Looking at our multiple comparison, it gives us an estimate, a standard error, and our arithmetic mean and estimate. And it also gives us our four options, our four levels: low, heavy, low, light, high, heavy, high, light. Now, unlike what you're used to seeing with your two keys test, where it gave you that ABC relationship to let you know where you had significant difference, another way to do that is to look at your confidence intervals. If your confidence intervals overlap, that means you do not have a significant difference. And so what do I mean by that? So if we look at the low heavy, we can see that our confidence limit goes from 13.3 to 18.6. If we drop down and look at the low light, we can see that it goes from 20.3 or 20.25 to 25.5. Those intervals don't overlap, meaning 13 to 18 doesn't include 20 to 25, and 20 to 25 doesn't include 13 to 18. These two levels are significantly different. In contrast, if we were to look at the high heavy, that goes from 10.47 to 15.7, that goes from, again, 10 to 15. We have overlap from the low heavy, which went from 13 to 18. 13, 14, and 15 are overlapping. Those are insignificantly different. So by looking at this, we can see that that low light is significantly different than the low heavy, the high heavy, and if we look at the high light, those three are insignificantly different from each other. Low light, in this case, would be the best level combination. We can do the same thing if we just want to look at the main effects. Go back to estimate, multiple comparisons. Let me see. So this was our body fat and smoking history. So let's just go ahead and select gender. Select OK. And we would still, again, take a look at that confidence interval. If we have overlap, that means we don't have a significant difference between male and female. And that's how they perform on our stress test. So if we take a look, female went from 11.6 to 15.4. Males went from 17.1 to 20.8. There is no overlap, so that means males and females perform significantly different on our stress test. Ideally, remember, we want the larger numbers because that meant they went longer on the bike. So it looks like males did significantly better than females on the stress test. All right, so that's pretty much everything you need to know for the jump output for the fit model report specifically. There might be one other thing that you might find interesting, and that's if you go to factor profile and select interaction plots. This will give you the two-way interaction plots, which you may find helpful. If you don't remember how to interpret these, you can find that information on slides 242 and 243. So we can see how our exercise tolerance did with, say, body fat and smoking, whether they're heavy or light smoker. And remember, if we have our lines intersecting or about to intersect, that tells us we have an interaction effect. We have lines that are more parallel, like, say, body fat and gender. That means we're not going to see much of an interaction effect. Although I suppose it looks like gender and smoking might be having even less of an interaction effect. But you can, remember, you can also see this numerically when we look at the FX test. Another way to look at our interaction plots, and something else that's going to be asked in the three-way ANOVA example, will be asking you to use the graph builder function. So if you go to graph builder, we can use our predictors and response to create these profile plots or interaction plots. So by drawing our exercise tolerance to the Y, we can drag and drop gender, body fat, smoking history where we need to put it. So you're always going to want to put one of these predictors on your x-axis. So in this case, I'm going to do gender. If we're doing a two-way interaction plot, we would put our second predictor under overlay. And don't forget, we're going to want to go in 6 from the left and make this into a line graph. So this gives us the interaction plot for body fat and gender. We can simply undo this if I can remove by dragging and dropping the body fat and do the same thing with smoking history. The red line is light, blue line is heavy. If we want to do the three-way interaction plot, we are going to drag and drop our third predictor, so in this case body fat, and we're going to put it under the wrap. And what it's going to do is it's going to put those two-way interaction plots side by side. And we can compare. We can clearly see that with body fat, when we had low body fat, those lines look pretty parallel, so there's not going to be an interaction effect. But when we are looking at a high body fat, we can clearly see an interaction effect present. So this is how we're going to do it for your profile plots. Drag and drop, keep the exercise tolerance on your y-axis, and then you can manipulate your predictors on the x-axis, the overlay, and the wrap function. Okay, so those should be all the jump skills you need for this homework. Let me just double check. Profile plots, effects test, main effects, yes. So it looks like we're good. Question 10 just asked us to do, a summation of everything you did. If you get confused of why we're following this process, the process of this whole example is based on slide 262. We are following this process step by step to find our best model possible. Okay, guys, that's it. That's all the help I'm giving you guys for the three-way ANOVA example. If you have further questions, email me. We can either Zoom or I'll do my best to answer your things through email. Have a good night.